All right. Hello, everyone. How's everyone feeling? The final talk of the conference. Hope everyone still have energy. Bear with me for another 45 minutes, maybe. So, yeah. Everyone can hear me, right? It's fine? OK. Cool. So, all good. Yeah, let's get into it, right? So I believe everyone here dealt with logs one way or another, right? So even like I imagine most of the people started programming, they wrote the first program, which is Hello World, which is nothing but putting logs somewhere, right? So either you are a developer or SRE, you deal with logs every day. So it can be from your own applications, from your dependencies, or from your infrastructure, right? So either you are using cloud or on-prem, doesn't matter. So you have logs from everywhere. So what can you do with all these logs? Can we make it useful? Can we extract something useful? But how? I'm Kavi. I'm an engineer at Grafana Labs. I'm also one of the maintainer of open source project, Grafana Loki. So today this talk is all about logs, right? And how you're going to manage the logs with a tool called Grafana Loki. Yeah, sorry, it's one more tool. Yeah, hope you guys bear with me for maybe 40, 50 minutes, I guess. So yeah, so the agenda is simple today. So first, we're going to explore and see what it feels like to use Loki, both as an end user who is consuming the logs, and also as an operator who runs Loki at specific scale, right? Then we'll take a quick sneak peek under how Loki works and some of the core abstraction and design trade-off, the way it has been designed. And finally, yeah, I will show you some of the patterns and practices we use internally to use Loki more efficiently. Yeah, that's our goal today. Yeah. So before jumping into Grafana Loki, I'm just curious, like, how many of you here can please raise a hand, like, know about Grafana Loki, already heard or know it exists? OK. And keep your hands up if you're using Loki. OK. OK, so then I think, yeah, we have something to learn. All right, so the picture at the bottom gives you a bit of an idea, like paints a mental model, what Grafana Loki is. So at least we like to market it as like a log aggregation platform, right? Horizontally scalable, highly available. But yeah, I'm not a marketing guy, just a database, to be honest. So the important thing to note here is it's multi-tenant. What that means is you have a single instance of Loki, and it can handle multiple users, and it's isolated at the storage level. What that means is no matter how many users are being served from a single Loki instance, so yeah, everything is isolated, like from a tenant-wise. So that's what I mean by isolation here. So it's a distributed system, so of course, yeah, it's highly available, and you can tune it to your scale as much as you want. And the important thing is, when it comes to bigger systems, right, I personally care a lot about its dependencies. So for Loki, the only required dependency is an object store. So it can be S3, it can be GCS, doesn't matter. It can be your file system also, if you're running in locally. So that's the only dependency you need. I mean, of course, you can build some kind of cache on top of it. You can put some cache for the performance, but that's not needed if you don't want to. So all the persistence data is going to lie only on the object store, and yeah, which is way more simple to operate, in my opinion. And it is built for developers and operators. That's what I mean. Like for operators, it gives you a freedom. Like the dependency is something operators always care about, right? So its only dependency is object store. And for developers, what I mean by that is, so being a developer, you've been often used to the idea of local CLI-based, like Unix pipes, for example, gripping logs or extracting something from the logs. So the idea here is, can we take that experience and make it modern, like cloud-native applications or at a bigger scale? That's what I mean by built for developers here. Yeah, it's open source, of course, like I said before. Yeah, if you don't like it, please help us improve. So yeah, it's also good to note what Loki is not. So one of the biggest confusion is when people coming to Loki is they try to use it as a full text search engine, like Elasticsearch, ELK Stack, or something like that, right? So Grafana Loki is not meant to be used as a full text search engine. Hold on to the thought. We'll come back to that when we talk about how it works and why that matters. And it's definitely not a storage for metrics, traces, or profiling. So what I mean by that is like we don't store any format related to traces or profiling or metrics. So that is an asterisk on metrics. What that means is using your logs, you can generate some metrics on the fly for your visibility, but we don't store anything on the like persistently in the object store. That's what I mean. And definitely it has nothing to do with machine learning or AI, and yeah, it's definitely not another ChatGPT. So let's get started, right? So how does it feel like using Loki? So so first things first. So even before getting something useful out of logs, you need to ingest them, right? So Loki has a simple model for ingestion. So basically, like you set up some kind of agent to scrape your logs. It can be from anywhere. It can be from, if you're running in Kubernetes, it can scrape from Kubernetes. It's a bare metal, doesn't matter. If it's like coming from some VM, also doesn't matter. So yeah, so you can choose your agent. So there is one come with Loki called Promptile, and there is also another thing called Grafana agent, which has a first-class support. And if you already have some agent like FluentD or FluentBit, also that also supports Loki. So the worst case, like yeah, Loki, it has a push API. You can just push logs directly to there, as simple as that. So another thing to note here is Loki ingestion is simple in a way, so it doesn't do any special processing during ingestion. So what it enables us to do is like it doesn't matter what format your logs are supposed to be. So it can be JSON, it can be log formed, it can be from systemd, it doesn't matter. So you just push it to Loki, and Loki is fine with it. And that is intentional because yeah, again, like one of the goal of Loki is for the simple operation, right? So also simple usability. So then once you ingested your logs, then it comes how do you query it back, right? So we have a language called LogQL. It's kind of like inspired from PromQL, from Prometheus, but customized mainly for logs. And yeah, it is just more than it is not like a grep, like where you can do only like some kind of matches. It's a bit more than that. We'll see how it works and what are the use cases. Yeah, and also so what I mean by that is like if you have some important information in your logs and you can do some kind of arithmetic on it. It's not like you can only match as a string or like some regex. So you can extract those information and you can do some arithmetic and joins and kind of thing. So that's what I mean. It's not just a distributed graph. So to give you an idea, this is how it looks like. So generally, like LogQL can be one of the two types. It can be like log queries, which looks something like this. So let's decode one by one, right? So when we talk about LogQL, so the important thing here is the selector, which is kind of like a labels idea. If you're familiar with Prometheus, probably you are more comfortable with this one. So here, this key value pairs, which is label, is more of like a topological information, right? Where we can locate your logs. How do you locate your logs? It can be from this cluster, this namespace, or it can be from this instance, or this can be from this app, or this from container. So all those topological information is mainly we put into these labels, which we call it as selector. In this case, for example, what it means is show me all the logs that is from the app equal to foo. The next one is we call it as line filter. By the way, if this seems familiar to you with all the pipes, that's also intentional. So that's what I mean by having the same local Unix pipe experience, right? So the second one, line filter here, So what this means is it's just a simple matcher. So in this case, what this means is out of all the logs coming from app equal to foo, show me only the log lines that has string error, that matches string error, right? And the next one is interesting. This is called a parser. So here it's JSON. We also support other parsers like log-formed and yeah, any other structural format you like to have, like a regex, for example. So once this has been parsed, like after the JSON, so your log line basically like converted into some kind of structural form, right? So then, for example, here the latency is actually a key in your JSON log. So now you can extract that latency and do some kind of arithmetic on top of it, right? It's no longer just a string, basically. So here, in this case, we are matching, okay, give me all the log lines from app equal to foo, and filter all the log lines that has only error, and then parse it as a JSON, then show me the log lines that has the latency more than 50 milliseconds, for example. So also one thing to note here, the 50 milliseconds syntax here, right? It doesn't mean like the latency key has to have the string 50 ms. So it can be like in any date format. The locule will understand it. So here you can be like 5 minutes or 5 hours, doesn't matter. So unless the latency is some date time format, the locule can understand it. Yeah, the final thing is like a formatter. So often we don't want the complete log lines at the end of the result, right? So we may want to remove something, we may want to rename something, we want to format in some way. So that's what this formatter comes in. So the idea here is if you're using logql to query your log back, and if it's a log queries, so the output will be your log lines, or at least some part of a log lines. That's what the log queries mean here. So in practice, this is what it looks like. And by the way, all the examples you will see here is from the Grafana UI. So the same query you can also use as a command line called logCLI, which also comes with Loki. But there are some limitations there. For example, how do you even show the graph in a terminal, right? So logCLI has some limitations where it can work with the basic log queries, which outputs a log string. But when it comes to metric queries, which we'll discuss in a bit, where you can also see the graph and tables, yeah, Grafana UI is a good alternative there. So in this example, so what's happening here is, first, like I said, the selector is telling, OK, give me all the logs from this particular job, DNSdemo/app. And again, yeah, filter only the errors from there. And then log-formed, this is another parser type. The previous we are seeing JSON, so here it's log-formed. So people who are in cloud native space or using Go mainly may be familiar with this pattern, log-formed. So this is like a flat key value pattern, right? So you have a key equal to value, key equal to value, and that's very flat. That's what the log-formed format here is. So yeah, you parse every log line as a log-formed, and then what you're doing here is show me all the log lines that has a message field which matches with this failed message. So what you're doing here is also like a regex. Yeah, so it's not like just pipe equal to. You can do like all sort of regex match as well. That's like an example of simple log queries. And yeah, the one highlighted here is your log lines. The other thing you see on the left is timestamp, which when your log is created or when it's ingested. So this is with the formatter. The only difference between this and the previous one is this one has the line format at the end, right? So what's the difference here is in the output. So previously, it's printing the complete log line. If you see the message, error, those are the two fields now, and also level, for example. Whereas here, you are just printing only the error message of all the log lines that matches this pattern. So yeah, so here the line format is itself is like one template. So here .err means like only print that error, but you can do all sort of template functions on top of it. So this is if you're familiar with the Go template package, so it supports everything. So whatever you can do with the Go templating, you can do within this line format template. Yeah, that's the idea. The next one is metric queries. So what's the difference here, right? So the one so that section, what you see here, it's almost same as the log queries, which you see previously, for example here, right? So the main difference with the metric queries is the output is no longer just the log lines, right? So what you're doing here is you are creating a matrix on the fly with just a log QL. So in this case, what it is doing is like all the thing that is being highlighted here, that's just a matcher, like give me all the logs from app equal to foo that matches error and parse it as a JSON, right? Then what we're doing here is, so the extractor one is kind of like optional. We will see some examples. I'll explain why and what if you don't use it. So what we're doing here is we are basically like, instead of just printing the log lines, for every log line, we are generating some metrics, which is nothing but some float 64 value, right? And we take past 1 minute of data, that's what that 1 minute stands for here, the function range, and we sum over the metrics, over the 1 minute of past data. That's what it is doing. And once you calculate that value, we aggregate by some label, like here it's cluster, sum by cluster. So basically what it is saying is, in a way like, from this app, show me all the errors and also sum it over the time and aggregate by cluster. So with this, we can get information saying like how often the error is happening in aggregated by cluster, in individual cluster, where this application is running. That's the idea. So this is what it looks like in practice. So here I'm using like count over time rather than sum over time. So this is exactly what it is doing, I was saying, right? So basically it is counting how many times the error has happened in this application in the last 5 minutes. So for example, and also we aggregate by the job comma error. So which means what error it has occurred, we also like aggregate by that one. So here in this case, for this job, TNS demo DB, it has occurred like 138 times in the last 5 minutes. And the error that happened is query log timeout, right? So this information like you generated just from your logs. So you don't have to instrument anything. You don't have to like generate metrics separately with any time series database or something. So this is generated just from your logs. So one thing to note here is this type, right? So metric queries can further be like two different types. Like here it's instant query, and this is the same query, but the type is range, right? And the one additional thing what you give here is also this time, like last 3 hours, right? So the previous query, what it did is it just took like last 5 minutes of data, and then it just tell you the count like a table. Okay, last 5 minutes. These are the different types of errors, and these are the different times it has occurred, right? So what you're saying here is, okay, show me how is it going for the last 3 hours, or for the last week or last month. So is the error rate has been like rising or decreasing or like or same? So that's the difference between like an instant query and the metric query. So instant query is just like a table, just gives you like a recent value, just a single value, whereas the range query is over a particular period of time, or a particular time range, basically. That's why it's range query. So I know like, so people who are coming to Loki from different background, like we can't expect everyone to learn the log QL, at least not easily, right? So we also have this thing called like query builder. So you can, instead of like writing the query and remembering the syntax and everything, you can also build this query via UI. So this is query builder in Grafana. So what this means is like you just go there and you just click the drop-down button. It will show you all the possible labels you can choose. And as you keep building, so for example, the query that you see on the bottom is built completely by the UI. So as a step-by-step, right? So first, you just select the label selector, like job equal to your app, name of the app, and then you just choose the line filter, which is just like a grep that has error in it. And then, yeah, you just choose a function. So this is a metric query, right? So what do you want to do with this? So okay, the error is happening from your application. So you are saying, okay, count those errors. How is it going? Like, I want to know how frequently the error has been happening, right? And yeah, then aggregate by namespace. For example, this query is running in Kubernetes maybe. So let's say in a single cluster, this application is running in different namespaces. And this query will tell you how frequent the error has been happening in, aggregated by namespaces. So that's like a bit of a gist of how the LogQL looks like, and yeah, how to use it, the very basics. So LogQL is like its own language of its own. Like, yeah, you can do all sort of things. Like for example, you can use different parser, different type of formatters, and you can also use joins here. So let's say you have a different application that is spitting out different kind of labels in different log lines, and you want to use labels from one application into another, so you can use joins. It's similar to like SQL join. You can also do it with LogQL. Yeah, so aggregation, like what we saw here is just a sum, but you can still do like a top K, for example. If you want to know, so here it show all the application aggregated by this namespace. Maybe if you want to know, like show me like a top 2 namespace that is having more error, right? So if you have like some kind of user ID, you can say, okay, show me what top 2 user affecting from this error kind of thing, right? So you can do all sort of aggregation as well. All right, so far, we have been discussing Loki, how to use Loki from the end user perspective, right? Like who wants to consume the logs and get some value out of it via LogQL. So that is the other side, like operators, right? Of course. So someone has to run the Loki. So we all been in this scenario, like being an SRE or operator. So and Loki, yeah, it's a database, right? So it's also like relatively new. So we have more features, we have more optimizations. So we also have this thing called like schema, like every database has. So whenever we do any optimization, with the index or with the underlying storage format, we change the schema version. So in this case, like let's say V11 is an old version and V12 is a new version, right? And yeah, and it's always good to have the latest version with all the improvements. But guess what? Who hates the updates, right? It's operators. So they don't want to update, like at least not the changes they not the changes they don't know, right? So this has been considered in Loki, meaning, for example, here in this case, right? So this is one of my favorite config of Loki. We call it as a period config. So what it is doing here is, so from, let's say, 2020, 1024, so all the data that is being ingested, also read from. So if it is from this period, just use this schema, like schema version V11. And starting from 2022, for example, use the other version, right? So all you need to do is just go tweak this config, and all your old queries, like anyone querying for the old data, and also anyone querying for the new data, should work seamlessly. Without any change. So that's what this period config is for. So this lets you to do easy migration, right? So think about this for a minute, right? So let's say Loki has this dependency like object storage. You are using GCS, and let's say your company, like your management, asks you to move to AWS S3, for example. So it's not like a single switch. What about the old data, right? So all you can do is go and change. Okay, I want to change to S3 from I don't know 2024 maybe, I don't know. So you just come and add a period config, and from 2024, you just point to S3, and that's it. So all the old, unless the bucket is reachable, the old bucket is reachable in GCS or Azure, for example. So those will work just fine. So when you combine this with what we're going to discuss next is like retention. It's very powerful. Like once, for example, let's say this is the config for retention. What that means is how long you want to keep your logs in the storage, and it should go away after that. So combining with this period config and retention config, the same example, let's say you want to migrate from S3 to GCS or GCS to S3. So all you need to tweak is this 2 config, and after this period of time, you won't have any access to like GCS, for example. So that's been completely, so once the retention period is reached, then all your data has been migrated already. So you don't have to do any copy of the old data. So yeah, that's the idea. So this is how the retention config looks like. And this is also per tenant. So what I mean by that is like this 29 here is a tenant ID or user ID. So it can also be like fine-grained per tenant. So when you're running a Loki at a large scale using tons of users, so you need a fine-grained control over what this user wants, right? Maybe one user asks for 1 year of retention. Maybe another user asks for 1 month, for example. And even worse, like even within a single user, you may ask for, okay, can you keep the dev logs for a little longer? I mean, the production logs for a little longer, maybe a year, whereas you can delete the dev logs in a month or so because you won't be needing it, right? So that's where this config comes in, like selector. So here you can be like, if any logs that is coming from namespace equal to prod, just keep it for more time. Whereas if it's coming from like another different namespace, maybe dev or something, then keep it for a different period of time. So you have like a more control over your retention as well. So yeah, I've been saying since the beginning, like, okay, Loki is built for scale and everything. So yeah, maybe this is just some numbers from our internal clusters. So we also run our own managed version of Loki. So if you want to use Loki, but you don't have to go through all the operators pane, so yeah, we have also like managed Loki version. So we just give you the URL and you just start sending logs, and you will have a Grafana UI you can start querying. So this is some of the states I picked up like this morning from one of the real Loki cluster. We have like bunch of Loki clusters internally. This is one from the largest cluster, which is serving like around 4,000 active tenants, and which is ingesting 16 terabytes of data per day. And on the query side, it's even more interesting. So we have reached like recently the throughput of almost 1 terabyte a second. People are like, the query has been processing like 12 petabytes per hour, and it's like 135 petabytes per day. So that's kind of like a scale we're talking about. Just to give you a mental model, when I say Loki is built for scale, this is the scale we're talking about. All right, so that's maybe painted a picture how the Loki is, like both from the user and also as an operator. So now what we're going to do is just going to take a quick sneak peek into some of the core abstractions of Loki and how it works. So the primary thing is the data model, like any database, right? So Loki has a very simple data model. So what I mean by that is like, so we are logs database, right? So every log line will have some kind of timestamp. And in Loki, like I said, it's also like inspired from Prometheus, where the labels has a bigger, bigger impact there. So this labels are what we call as key value pairs, and then your actual log line, right? So the interesting thing to note here is we don't index your log, and we are logs database, right? So what's happening here? So we index only the timestamp and the metadata, which is the key value pairs you send, and that's it. We don't index your logs, right? So you may be wondering now. So what's happening? Like if you don't index your log, then how can you find your log in an efficient way, right? So by running systems at scale, we realized in any database where at some point in scale, if you index everything that is coming in, at some point in scale, you're going to reach where your index size is much more than your actual data, right? So if you do full text index of all the logs that has been coming inside your system, then your index size is going to come and hurt you at some scale. So it's going to be much significant, like orders of magnitude bigger than your actual data at some point in time, right? So people who has run ELK or like any other full text search solution probably know the pain. So that's kind of like a trade-off here, right? That's been in design. So that's one of the pain points we want to solve. Easy for the operator to not to go through this handle huge index size. So if you think about it, right? So at that scale, then you have some different problem. So now your entire query path depends on the bottleneck of index size. Because every query you need to serve has to come through this huge index, then you need to do all kind of hacks to keep this index always active, either in memory or some kind of close to the memory address space, right? And yeah, so Loki completely eliminates this problem. That's by design. And yeah, one more thing I also wanted to point out is this combination of unique labels, we call it as a stream. So what this means is like a single unique stream can be like inject like multiple log lines. So from this cluster and namespace, you'll have tons of logs coming in. So that's the stream in Loki terms. So yeah, so another thing maybe, if I were you, I'll be asking the question, okay, how does the query path works, right? So if either you are from an academic background or a practitioner, you might be wondering, okay, hold on. So you don't index the log line, then how can you make your query faster, right? Because that is this conventional wisdom where, yeah, like I said, like either you are from practitioner or from theoretical background, if you want to make something fast, you index it, right? That's the wisdom we all been taught. So we like to challenge that idea, because the problem I said before, right? So if you index everything, then you have some different problem at scale, and that's the thing we're trying to like find a balance here. That's a design trade-off I was talking about, right? So then how do we make a query faster, right? I showed the stats there, like 1 terabytes per second, our biggest cluster. So how does that even possible? So Loki, in Loki terms, like Loki leveraged this horizontal scaling idea, meaning, so I can give you an analogy, right? So let's say you ask any full text search engine, so hey, where is my log? So it can tell you it's in page 50, right? If you ask the same question to Loki, it's not going to say it's in page 50. It's going to say, hey, your log can be between page 50 to 100. And Loki will use 50 machines to go and find that log. So that's the different trade-off there, right? So Loki takes advantage of horizontal scalability to have that control. So yeah, the important point here is the control, right? So you start using Loki or any logging solution. So having that control to tweak it and change your performance based on your needs, that's the key here. So if you want more performance, all you need to do is just add more queries, right? So you don't have to deal with all the big indexes at scale. So this is how it works. Don't let the image scare you. So the idea here is, let's say you have a query on the top, right, which is doing some log here. Let's say this query is asking for data of 1 hour, right? So as soon as it comes into Loki, what Loki does is, first it will do some kind of splitting. So it say like, okay, I'm not going to execute the query all at once. I'm going to split this as 15-minute query, right? So already now a single subquery has to deal with only 50 minutes of data, right? So this is what we call as query splitting. And further, we do some kind of sharding over the data, right? So this is like very dynamic. So we build the index in such a way so that just with the index, you can tell how much data this query is going to touch. So this is very dynamic, and you can split the query and shard the query as much as you want, depends on how much power you have based on the queries, and you can schedule those sub-queries to them, right? So yeah, this is how we make the query faster without indexing everything. So we take advantage of the horizontal scalability. So yeah, this is another states I took this morning. So I've been saying we do less index, right? So to paint a picture, so for like around like 37 terabytes of data, so the index size is almost 140 MB. So also like a fair warning here, this doesn't mean always this is the case. You always like 140 MB for 37 terabytes of data. This is from one of our cluster. So the data is real. So think about this for a sec, right? So this 140 MB of index, you can load it in Raspberry Pi. So it can be always in memory. So every query that is coming into your system is no longer bottlenecked by the index size at all. So this can always lie in a memory, in a main memory, right? So that's a trade-off we are talking about so how we built Loki. Yeah, that's about like how some of the core abstraction works in Loki. So finally, I want to show some of the patterns we use internally to show you like what are the patterns that like you can use Loki if you want to adapt. So the one thing to note here is, since at the end of the day, Loki is also an application, splitting out logs, right? So a lot of examples I'm going to show is coming from Loki itself. So we use Loki to monitor Loki. So yeah, it may be funny, but so first things first. So in order to get something useful out of your logs, you need to put something inside, right? So for example, this is a real log line from Loki server itself, like Loki database itself. So for every query that is coming into the Loki, we just log this one line with some like a metadata. For example, who runs this query, like a user ID, and trace ID if you need more information, and then exactly what query that is being run, and then what query type. So like I said, it can be like a log query or a metric query or range query. And length here meaning is it like a day-long query? Is it like a week-long query? How long the query touches, basically. And the duration is actual duration the query took to run. And status, of course, yeah, is it success or failure? Throughput is also an interesting one. So total bytes is also how many total bytes the query has touched to the completion to return the response, basically. And the chunks download time is also interesting because, like I said, one of the Loki main dependency is the object store itself. So we use this a lot. Let's say when the GCS has outage, we'll have some increased value here because we'll know where the time has been spent. So if the time is being spent mostly in downloading the chunks from the underlying storage itself, so that's a signal where something wrong with the storage itself. By the way, this can also mean there is something wrong with our caching, right? So ultimately, your chunks or your log data can come from the cache, but if it's still touching the storage, then that can be something wrong there as well. So queue time is also an interesting one, which tells you how long the subquery or query has to wait before being picked by the courier and run. So this is a good sign where you may have to go and scale. Like this may be like a good sign where you have more usage of your Loki. People are using more, and you need to scale it more because a lot of the queries are like kind of like stuck in the queue. You don't have enough couriers to run it. Source is also an interesting one because the query can be from different sources, right? It can be like a part of alert, or it can be from log CLI, it can be from Grafana, or it can be from different way, from API, for example. So yeah, we also track this one. So the below is a real example from the log line itself. Yeah, so it's basically like telling you this 1, 2, 3, 4, 5, 6 user ID has run that query, and it took this much time, touches this much data, kind of thing, right? So by having this log line, we can do a lot of interesting things, actually. So what is happening here is the one highlighted here is a log query. So we run our Loki in a Kubernetes cluster. So what this is saying is, so give me all the log lines that is coming from query frontend, which is a component in Loki, from this namespace and this cluster, where caller is equal to metrics.go. So this is a convention we use internally. So the log line you saw before is basically coming from this file, metrics.go. It can be varies, depends on the use case, but yeah. And you just parse it as a log font. And then so what you're doing here is like, after parsing, you will have this arg ID or user ID here. Can be matched with any pattern you want. It can be like a single user ID. Let's say there is a user complaining, hey, all my queries are slow, right? Or what is happening to my queries that is being run. You can choose that arg ID and you can know all the information, how long those queries took and so on and so forth. So yeah, this is what the unwrap means. So before we have seen just a count over time, right? So count over time just generate the metrics based on the log line. Each log line is counted as a one value, and then it just generates the metrics on top of it. Whereas unwrap you can tell how you want to calculate. So instead of using just a count, just use this total bytes field in the log line. That's what it's saying. So basically what this query will give you is per second rate for the last 1 minute of data. And basically it will tell you like how many bytes being touched by this query, like how many data has been processed by these queries for this period of time. So with this logql, you will get the graph like this, basically. So for this one instance of Loki, this give you how much data that is being processed by this Loki instance. Yeah, which is good to know when you operate big Loki clusters. So this is another interesting thing. So sometimes, yeah, people come to and say, this particular query is slow, and we want to know why, right? So with this query, what we are doing here is we are out of all the queries that is being run, show me the queries that took more than 10 seconds, duration greater than 10 seconds. That's what this means, right? And show me all the queries that took more than 10 seconds, and also that processed more than like 4 gigabytes per second with the throughput. So yeah, so with that query, you'll get some table like this. These are like a real dashboard from one of our internal cluster. So here it will show, like, for example, top 4 queries, slow queries here, right? So and out of top 4 slow queries, the 3 queries are from same user. And there is also this query hash. So this is useful like to filter out whether the user is running the same query again and again. It can come from like dashboard that is auto-refreshing, right? So we don't know. So it can also help us to figure that out. And the important thing is at the bottom, you get to have some filters. So this is like a dynamic, right? I can change to 20 seconds instead of 10 seconds. And I can, I can play with these values. And I can also filter based on tenant here. So if I want to look for, hey, show me all the slow queries from this tenant, I can choose the value. And also show me all the metric queries that is slow, I can also choose that. So yeah, just by having that one log line in your application, yeah, you get to have all these nice things. Yeah, there's a couple more things I want to share. So the ones we see before is metrics generated out of your log lines, right? So you don't need to instrument your code or anything, just from the log lines. And not only that, you can also alert based on your log line. So if you find something weird in your log lines, you can also trigger alert based on that log line. So what's happening here is, this is a logql, this is a valid logql. So what basically happening here is, if there is like a panic happening in this particular application called Cloud Logs Archiver, and we take like last 10 minutes of data and see how much panics that has been happening, And if it has been happening for, if it is even more than one panic happening, and that has been happening consistently for 10 minutes, page someone. Something is wrong, right? That's what this does. So cool thing about this is, since we also have this metadata along with your log lines, so you can use that metadata in your alerting messages, for example. So which application is throwing this panic, and how long it's happening, and what's the rate of panic, for example. So that's what this value means here. In order to send these alerts, you need some kind of receiver, right? So if you're familiar with Prometheus world, so that is this thing called like alert manager. So Loki also supports this endpoint. So if you already have alert manager, you just have to like point that to Loki config. And you have to point the Loki to alert manager URL. And and when any alert happens, it just send the alerts to alert manager. And from alert manager, you can have any receiver you want, like Slack, email, PagerDuty, doesn't matter. Just from your logs. And another thing is something called recording rules. Also should be familiar if you're from the Prometheus world. So what this means is, like I said, when you want to generate some metrics out of your logs, so sometimes it's very expensive, right? So for example, this query here, so if you run this, it's like a bit of an expensive query. What it is happening here is, so it calculates like a 99th percentile of the queries, and if it is something like abnormal, like a low latency or like a throughput is very less or something, so you can't make this query very frequently because it's expensive, first of all, and it's going to take a long time if you want to do anything with it. So instead of doing as an ad hoc query, what you can do is you can create as a recording rules. So this recording rules runs in the background. We have a separate component called ruler, which takes care of this one. And whatever the metrics generated by this query will be sent to some Prometheus compatible store, right? So then you can use that metric as a normal metrics. Like you don't have to make this logql every time. You can just use that metric directly. So that's the idea. So it's similar to recording rules in Prometheus also, if you're familiar. So for example, so this is not a logql, it's a promql. So and that's exactly the metric we generated via recording rules. So whenever you run this one, this already been computed, so it's very, very less expensive. And you can also build dashboards on top of it. So again, the other side of it, right? So far we have seen patterns of using Loki as an end user, like who is consuming logs. There is also other user, which is operator. And this is one of the essential config when you run Loki at scale. So what this means here is, like I said before, Loki is mainly about this horizontal scalability, right? So let's say, so at the end of the query path, it's all the queries that picks the subquery after splitting and sharding. It just runs it, right? So what this max concurrent will do is how many subqueries a single querier can handle at the same time, like parallelly. That's what it says. So why it matters? Imagine like, you have a query, you're running a query on a machine with 8 CPU, right? So you can choose this config based on how many cores you have in that machine to make it more performant, more utilized, right? And the other config, which is max query parallelism, this is also like per tenant. So this controls how many queries can be scheduled at the same time. So let's say you have a Loki instance that is serving multiple different types of users, right? And you need, so these users can be from different teams inside the organization itself. So you want to have more performance, you want to give more performance to some teams, and you can tweak this value. So it is per tenant. So in this case, if any, let's say, tenant ID or user ID like 1, 2, 3, 4, they can have max parallelism of 64, which means at any point in time, like a 64 queries for them will be scheduled before waiting for another query to execute. That's the idea. Yeah, that's not all. Yeah, if you find any of this interesting, come and talk to me. Yeah, so there are so much more that I didn't cover here. So also Loki being like very relatively modern, we have a lot of ideas floating around as a future improvement. For example, one of the things we are currently working on is query planner. So you can think of like explain in SQL, right? So what this means is, so it will give you some kind of report, like how much data your query is going to touch, so that you can optimize your query yourself, kind of like SQL explain. And also like a query scheduler improvements. So this is something like if a single user is running different types of queries, and one is for alerting, and one is for some ad hoc queries for debugging. So which one to give more priority, right? Because the alerting query is more priority maybe, because if there is no alert is firing, then maybe something terribly wrong. So those some kind of query fairness within the single tenant. Yeah, maybe secondary index, right? So like I said, Loki doesn't index everything, only labels. So maybe there is a more trade-off you can make there, I don't know. So yeah, to summarize what we saw. So the takeaways I want to have by the end of this talk is, so Loki is just another database built on top of object store, and it is mainly designed for the logs, right? And it has only object store as a dependency. And it has simple ingestion, and the query path is mainly focused on like the parallelization rather than indexing everything, right? And yeah, it's built for operators, easy migration, retention. Like it's own just two simple tweaks, and you just don't have to worry about the retention anymore. Yeah, in how it works, we saw like data model, how it's simple, and we deliberately made to keep the data model simple, which helps in yeah, running Loki at scale. Yeah, different logging patterns. Like we saw, like just having single useful log line in your application, you can get so much out of it Loki with a few log QLs, basically. Yeah, that's pretty much it I want to share. And yeah, thanks for your time. Thanks for listening.